Hello, Dan Nedolkowski here from howtomechatronics.com. In this tutorial, we will learn how to make an Arduino-based DIY vending machine. I will show you the entire process of building it, starting from cutting and assembling the MDF boards to connecting all electronic parts together and writing the Arduino code. You might be thinking now that the item carrier is not so useful for this vending machine. And yes, you are probably right. But my idea here was to make this project more interesting, or a bit more complex, so you can learn more new stuff. I think this project idea can be great for electronics or mechatronics students considering building one as their final year project, as well as for any Arduino enthusiasts. I started by cutting the 8mm thick MDF board to size. I previously made a 3D model of the machine from where I got all the measurements. You can find and download the 3D model on the website article. For cutting the MDF, I used a circular saw. Actually, this is a homemade workbench featuring a circular saw, a router and a jigsaw made by my partner Maria, and there is a DIY video for it on her YouTube channel, Creativity Hero. The link to it will be in the description of this video. After cutting all panels using the circular saw, I continued with making the openings in some of the panels using the inverted jigsaw. Actually, a jigsaw can be even used for the previous step in case you don't have a circular saw. I also used the jigsaw for cutting the smaller parts, which had several cuts. However, note that these are dangerous machines, so you need to be very careful when using them. Once I had all MDF parts ready, I started assembling them using some wood glue and screws. For fastening the panels, I used 90° angle clamps. Using a cordless drill, I first made some pilot holes, then I made countersinks and screwed the 3mm screws in place. I used the same method for assembling all panels, and for some of them I also used some F-clamps. At this point of the assembly, I will continue with making the rail system. For that purpose, I am using aluminum tubes, which I cut them to size using a metal handsaw. The diameter of the tube for the horizontal rail is 16mm, while for the vertical rail the diameter is 20mm. On a solid 18mm wood boards, I made slots for the tubes using Forstner bit, and then attached the tubes to them. The horizontal rail is made out of 27 cm long tubes, while the vertical rail is made out of 3 45 cm long tubes. Next are the sliders, and here's how I made them. I used 21 by 21mm wood board on which I made 8mm holes. Then I inserted 8mm threaded rods through these holes and using washers and nuts I secured the 22mm bearings. As for the horizontal slider, I used the same method, but with smaller bearings of 16mm in outer diameter. After I inserted the slider in between the tube rails, I noticed that it was a bit loose. For solving this problem, I had to reduce the distance between the two rails. So first I expanded the tube slots, then I made perpendicular slots through the tubes, and finally, using threaded rods, I fastened the two tubes rails closer to each other. After this, the sliders were no longer loose and they worked properly. However, at this point I had to disassemble the rails in order to add the other elements to it. First, I added a 5mm bolt on the left side of the rails on which I will attach a pulley for the horizontal timing belt, as well as the two more bearings which will slide on the left vertical rail. On the other side of the rail, I had to attach the stepper motor for the horizontal movement. For that purpose, first I fastened the motor on a 8mm MDF board, then added a supporting piece of wood to it, and also secured the slotted part to it. Finally, I attached this whole assembly onto the vertical slider using a wood glue and two screws. Next, I continue with adding the container of the horizontal slider. For that purpose, I used some small pieces of wood which I joined them together using a wood glue. Once I was done with this, I was ready to assemble the rail system. I used some epoxy in the rail slots and added an additional wood board to the side of the rails to make the whole system stiffer. In the next step, I inserted the assembly in between the vertical rails and secured them in place as well. The final result of the sliders and the rail system turned out to work excellent. I continued with installing the horizontal timing belt. I measured the length I needed, cut it to size and secured it to the slider using a zip tie. As for the vertical slider, I attached the stepper motor on the top of the machine using a piece of MDF and some bolts. At the bottom, I attached the pulley and in a similar way installed the timing belt. Next, I moved on to the item discharging unit. I made a helic coil out of 3mm thick metal wire by wrapping it around a 7 cm in diameter spray paint can. After that, using a glue gun, I secured it to the continuous rotation servo motor. Next is the front door panel, which I attached to the machine using simple hinges, and for locking it, I used a magnetic door catcher. Then I used 5mm thick acrylic to cover the big front opening, while for the smaller opening on the right side, I used a very thin aluminum plate. Here I made fork holes for the buttons, as well as openings for the coins and the LCD display. I used a drill and a hacksaw for making them. Once I attached the electronic parts to the aluminum plate, I attached them to the front door panel using 5mm bolts. For positioning the carrier to its starting position, I installed two micro switches. And for the coins, I glued a guide which will guide the coin to slide to the bottom of the machine. The coin detector is a simple infrared proximity sensor, so when a coil will pass near it, the sensor will give a positive feedback. Next comes the fun part, connecting all electronics components to the Arduino board. Here's the complete circuit schematic for this DIY vending machine project. So we need 12 volts power supply with at least 2 amps. We need the 12 volts for the two stepper motors as well as for the LED strip lights, which I will later attach on the front door. However, for all other components we need 5 volts, so therefore I used a buck converter to step down the 12 volts to 5 volts. The DS04 continuous rotation servo motors are powered with 5 volts and controlled via PWM signals coming from the Arduino board, while the stepper motors are controlled via the A4988 drivers. The 4 buttons and the 2 micro switches are connected to ground and the Arduino digital pins, and with using the internal pull-up resistors of the Arduino board, we can easily detect when they are pressed. Of course, you can always check my detailed tutorials on how to connect and use each of these components individually. I connected the electronics components using some jump wires. It became a little messy with that much wires, but everything worked properly. At the end, I attached 2 LED light strips on the door panel to illuminate the inner of the vending machine. What's left now is to program the Arduino, and here's the code that I made for this project. First, we need to include the servo and the liquid crystal libraries, define the LCD pins, the 4 servo motors, the stepper motor pins, the coin detector, as well as the 4 buttons and the 2 micro switches. In the setup section, we set the pin modes for each of the mentioned pins above. We can note that for the buttons and the micro switches pins, we activated the internal pull-up resistors. This means that the logic level at these pins will be high all the time, and once we press them, the logic level will drop to low. Before entering the main loop, we also set the carrier to its starting position, which is defined by the 2 micro switches. So with the while loop, we keep moving the carrier to its starting position, and once the 2 micro switches will be pressed, the motor will stop and move to the desired starting position. In the main program, we start by printing on the LCD the message "Insert a coin". Then we get stuck in a while loop. Once we insert a coin and it passed near the proximity sensor, the logic state at the coin detector pin will drop to low, and in that case we will get out of the while loop using the break statement. Then we print the message "select your item" and we get stuck in another while loop. This while loop waits for us to press any of the 4 buttons, and once we do that, we get out of it and print the message delivering. Now, depending on the pressed button, we execute one of the cases in the switch statement. In case we have pressed the first button, the carrier will move up using the custom-made move up function. If we take a look at this function, we can see that it simply sets the stepper motor to move in a particular direction and makes the amount of steps that we entered as argument. We can note here that I set the A4988 stepper driver to work in a quarter step resolution, and with some testings, I concluded that I needed 4,900 steps in order the carrier to get to the upper position. In similar way, we move the carrier to the left until it reaches the location number 1. Right after that, we rotate the continuous rotation motor for 950 milliseconds so that the helicoil make a full cycle. Note here that these values can sometimes vary and depend on the motor itself. Then, using the move right and move down custom functions, we bring the carrier back to the starting position. In the same way, we can discharge any of the 4 items. At the end, we just print the message "item delivered." So it's that simple. I hope you enjoyed this video and learned something new. Thanks for watching, and don't forget to subscribe and visit my official website howtomechatronics.com for more interesting projects.